Hey folks, I'm Ben O'Shea, Senior Reporter at the West Australian and host of the Newsworthy podcast. And it's my great pleasure to welcome you to the Western Australian Museum Bullabardip. I'd like to start by acknowledging that we meet today on the lands of the Whadjuk people of the Noongar Nation and pay my respects to their elders past and present. Now, before we get started, just a bit of housekeeping. In case you need the toilets, they're just back out there and to my left. There's also a water station at the back of the room in case anyone needs it. And in the event of an emergency, please follow the instructions of museum staff. Okay, so today we have an extremely exciting opportunity to collaborate with ocean exploration non-profit OceanX. And this includes an exclusive live feed from the research vessel OceanXplorer while it's on a science mission in international waters off Java, Indonesia. And they'll be beaming back to us here at the WA Museum. It's truly an incredible floating science facility. So let's take a look. Wow, I think that's worth a round of applause. And now the WA Museum is proud to be presenting the OceanXperience, an exhibition that takes visitors on a journey to explore the unknown outer limits of our oceans and experience what it's like to conduct mission-critical science aboard OceanX's research vessel, the OceanXplorer. Hands up who has already been to the exhibition. Okay, that's pretty good. After this, I'm sure all of you will want to check it out. It's an incredible exhibition. It's also a significant moment for WA marine science, with a strong contingent of West Aussie researchers aboard the OceanXplorer, including researchers from the WA Museum working alongside colleagues from the University of WA and Minderoo Foundation's Oceanomics team. We're also pleased to have the WA research team currently working on Christmas Island joining today's live stream. So a shout out to everybody in Christmas Island. It's great to have you with us today. And just to give you all a heads up, a bit later you'll get a chance to ask the scientists on board the OceanXplorer a question yourself. But first, I think we need to introduce them. Dialing in today with us, we have Dr. Alexis Wenig, who is the Science Program Manager at OceanX. Alexis is a deep sea ecologist and marine scientist with over a decade of experience. With a PhD in biology, she has participated in more than 20 oceanographic expeditions. And also with us, we have Dr. Jen McIlwain. Jen is a science and research leader with a PhD in marine ecology. As Director of Science at the WA Museum, Jen leads strategic research initiatives and multidisciplinary teams. Folks, can we get a round of applause for Alexis and Jen? We're very excited to have you both with us today. Alexis, I want to start with you. Can you tell us a little bit about the Ocean Explorer, whereabouts on the vessel we are right now, and can you tell us what your role is?
Sure. Thanks, Ben. It's really great to be here with everybody today. We are in the sub-hangar of the Ocean Explorer. So the
Recording
Ocean
in progress.
Explorer is our research vessel that we operate and has multiple different types of assets. So our submersibles that people can get in and go down to 1,000 meters is one of our favorite ways to explore the deep ocean. But we also have other assets like the ROV, which you're going to see later today. I am the science program manager for OceanX, so I oversee all of the science that we do internally and then also bring partners together to be able to do these awesome projects like we're doing with WAM.
Amazing. And Jen, can you tell us where exactly in the world the vessel is right now? What is the significance of that location? And then where is the expedition going to take you?
So we're currently approximately 700 kilometres east of Christmas Island and about 1,000 kilometres northwest of the Northwest Cape in Australia. Just for those of you, just to give you some sort of perspective about where we are. Which is in the northeast Indian Ocean. We're currently over some really interesting looking seamounts. These are literally sort of mountains in the ocean from the seafloor rising up to about 2,500 metres. And they've never been mapped before, they've never been explored before. So this is a really exciting opportunity for the WA Museum to partner with the OceanX and also other WA institutions to explore this just incredible environment.
And Alexis, just quickly, what is that behind you there?
This is our submersible named Neptune. So we use this submersible to go down when we're working in places a little more shallow than where we are today, because these can go down to about 1,000 meters. They allow us to collect video as well as physical samples. So we have a suction sampler, we have the arm that allows you to grab things, and that way we can bring samples back to study them later.
Yeah, fantastic. Okay, who would like to see a bit more of the ship? Yeah, we're getting a lot of hands up down here at the WA Museum. Alexis, any chance we could see the wet lab where a lot of the science happens?
Yeah, sure. So we're going to go on a little journey to the wet lab. So this is the space where when the samples get brought back on deck after an ROV dive or after a sub dive, the samples get processed by the scientists on board. And so that means that they can be cataloged, they can be preserved and made ready for once we get off the ship to do a more in-depth analysis. You'll see that we're walking around. So this is within the sub hangar. So we have both of our subs as well as some other machinery that we operate throughout the different missions. So over on this side, we have our wet lab. So this is where we would bring all of those samples and start to work with them. So we're going to move these right over here.
And so it's very exciting having WA marine scientists from UWA and Minderoo Foundation's Oceanomics and our own scientists from the Western Australian Museum on board OceanXplorer to explore these deep sea ecosystems. They've been on board since the 4th of July, undertaking an ambitious research expedition spanning the Indo-West Pacific. The expedition aims to document marine diversity across some of the region's most remote and least studied ecosystems. Using OceanXplorer's advanced technology, the team is undertaking careful deep-sea specimen collection with remotely operated vehicles, or ROVs, as the cool kids say. These ROVs, see, sounds pretty cool, use ultra-high-definition 4K image capture of sensitive marine habitats, and they're conducting environmental DNA, or eDNA, sampling to better understand species diversity and ecosystem health. The expedition will also investigate a range of remarkable underwater features, including seamounts, underwater mountains that rise thousands of metres from the seafloor but still remain hidden beneath the ocean's surface. These geological features can create unique habitats and act as biodiversity hotspots, attracting a rich variety of marine life. Despite their ecological importance, many of the seamounts and slopes in this region have never been visually explored or scientifically sampled. Okay, I can see now we're at the wet lab. So Alexis, can you take us through exactly what it is, what sort of work you do there, and what role it plays in the broader mission?
Yeah, so when we come into the wet lab, it's a space that allows for bringing the samples, whether they're still alive or they're ready to be preserved. And so similar to what you see here, I'm going to kind of hold these up to the camera. These are samples that have been brought up from the ROV, as Ben was talking about, so from deep on the seafloor. And by bringing these to the surface, it allows the scientists to be able to better identify, to know exactly what species it is, and also to take samples to sequence the DNA. And that's important so that we can know exactly what is the community on that seamount made up of, and what are kind of like the members of that neighborhood. It allows us to really understand the ecosystem better. The wet lab is important because it's a place that all of the samples come to, and they all get the expert attention that they need before we can take them off the ship to bring them back to places like the Western Australia Museum so that they can be worked up, and really the scientists can spend a lot more time studying them.
Yeah, well, the WA Museum's participation builds on its ongoing partnership with Minderoo Foundation's Oceanomics program. And together, the organisations are advancing the use of eDNA technology through the collection and analysis of water samples across Western Australia. Jen, I'm hoping that you can tell us more about eDNA, how you're collecting it, and what's the significance of this kind of research.
So we've got Lauren here in the wet lab, and she's currently filtering water that's being collected. And the importance of this particular collaboration is that we're able to, the Oceanomics team are able to collect water at the same time as we're collecting our specimens. And what they're doing is eDNA is basically fragments. All animals shed fragments of DNA into the water column, marine organisms. And what they do is that they filter the water, collect those fragments, they amplify it, and then they take the sequences of DNA, and then they go looking to see what kind of species that exist in the water column. So it's this really clever way of identifying species without actually having to collect. But what we do is we're sitting alongside the Oceanomics team, and we're helping them with the taxonomic identification of those of that DNA. So it's a really critical partnership. And this is the first time we've been given the opportunity to work together in these very deep water environments.
I hope some questions are percolating in everyone's minds here as you listen to that. It's absolutely fascinating. Okay, so let's keep the tour rolling. It'd be amazing to see mission control on the OceanXplorer. Alexis, would you care to give us the tour?
Yeah, absolutely. We'll head that way. So it's going to take us a little bit of time to get there, so it's just a kind of back tour of part of the ship, so you'll get to see a little bit more of where operations are happening. So we mentioned earlier about having an ROV, or a remotely operated vehicle. So our ROV is currently in the water doing an active dive, and so as we come through this area, you'll be able to see that the ROV is down over the side of the ship, and it is connected to that wire, that tether. So you can see the ocean out there, you can hopefully see the wire, and then we're gonna head into mission control where you can see what the pilots and the scientists are seeing while the ROV is exploring.
The weather looks pretty good today, Alexis.
Yeah, we're lucky today. We have pretty good weather. It can be a tough place to work, the Indian Ocean, but it's very much cooperating with us right now, so we're really fortunate. So we're gonna head in to mission control. So as you go in, you can see that we have lots of people working in here at the moment. So you can see in front, these are all the screens that the ROV pilots and the scientists are using to understand what's happening underwater with the ROV right now. And then we're gonna walk around this way to give you guys just a little bit different view.
Alexis, can you tell us what the researchers there are looking at on those screens, the role mission control plays, and tell us a little bit more about how you use ROVs in your research.
Absolutely. So first, I'm going to kind of introduce who is here right now so you guys can see the people in action. We have 2 ROV pilots. So we have Colin waving at you, and we have Ewan, our pilot, over on the other side. So their role is to make sure everything that happens with the ROV is happening well. They're engineers, they're pilots, they have multiple roles on board to make sure that we're doing our operations safe, and also like they're incredibly good at doing their job. So making sure that we get great video and we get great samples. And so what we're doing right now is the scientists are in the back row here, our scientists from the Western Australia Museum, and they're leading in the dive, meaning that they're telling the pilots what they'd like to do, what they'd like to look at, and what they'd like to collect. And that allows for them to get the samples that they're interested in from eDNA, like Jen talked about, as well as other collections that we bring back on board and into the wet lab. And so what they're looking at right now on the screens is, they're looking at a coral right now, which is my favorite topic. And then they have some brittle stars on top. And you can see there's a bunch of different screens. And that's so that they can see what's happening all around the ROV, because it's a robot that's essentially 3,000 meters down on the seafloor right now. And so we have 6 cameras that allow us to look at what's in front of the ROV, what's underneath the ROV, what's behind the ROV, and what's on the left and the right of the ROV. And then we also have some other instruments and screens that allow the pilots to make sure that all of the mechanics are working well and that we know exactly where the ROV is in relation to the ship. So it's a complicated operation, but this team has it down really well to make it look easy and efficient.
And how does the ROV then collect specimens if you see something that you would like to bring back to the vessel?
Yeah, we have a couple different mechanisms, and actually they're doing one right now. So you can see Colin right here has this apparatus in his arms. And so it is essentially a small version of a large mechanical arm that's on the ROV. And so he's using that to control how he is moving that arm underwater. And what he has grasped in the arm right now is what we would call a suction sampler. So it's a tube that we can use suction power to bring whatever animal they're interested in getting, and it'll bring it back into a chamber that's located on the ROV.
Yeah, incredible. And at that depth, at 3,000 meters, can you give us an idea of the sort of the pressure that the ROV would be under?
It's under immense pressure. So one of the reasons that we use ROVs is it's very difficult to work in these conditions. There are submersibles that can do that, but when we get down this deep, the pressure is so intense that it requires really, really specialized equipment in order to work there. So the ROV is unmanned, meaning that it's a robot down there operating from the guys doing it up here on the surface, but there's nobody physically in the ROV.
Because what we're talking about here, folks, is the deep ocean. It's Earth's largest and least explored habitat. More than 70% of it remains unmapped and unexplored. And we know less about some deep sea environments than we do about the surface of the moon. How crazy is that? Western Australia borders the eastern reaches of the Indian Ocean, the world's 3rd largest ocean basin, and one of its most environmentally diverse marine regions. The Indian Ocean encompasses vast deep sea landscapes, including canyons, seamounts, abyssal plains, and trenches. These remote environments provide habitats for remarkable species that have evolved unique adaptations to survive in conditions of complete darkness, intense pressure, and extreme cold. Jen, I want to talk a bit more about how ROVs have made deep sea research possible. Can you tell us about what it might see at the depths it's at today, and what are you looking at?
So ROVs, of course, were developed as part of the oil and gas industry. They're used extensively for laying cables, repairing of pipelines. But in terms of science, they're not used that extensively well, certainly not in Australia. So this opportunity for us to access an ROV has been really, fantastic for us, because it gives us access to habitat like this sort of rocky, sort of basalt environment that we wouldn't otherwise be able to sample. And you can see that.
Oh, I think we've lost Jen there for a second. I'm sure we'll get her back, but we can see incredible footage from the OceanXplorer of how they get those samples using the ROV.
Incredible communities of hard corals. Oh, what have you seen? You've seen something? No? We saw a holothurian, a beautiful sea cucumber that I don't think we've collected to date. So I think the staff were getting a little bit excited. So yeah, really interesting communities that we really weren't anticipating, and much more diverse and abundant that we would ever have hoped. So it's been incredibly fruitful for us from a collections perspective and an ability to be able to, bring these samples back to the museum for us to be able to study.
Yeah, Jen, I can imagine everybody would gather around the screens there to see, what the ROV might discover. Can you take us through what it feels like when you see something that is unknown, that you haven't come across before, that might be completely new to science?
Yeah, there's certainly that aha moment you get when you see something that you've never, is potentially a new species. There is a little bit of whooping and jumping in the air, and when someone like Alexis, who has got so much experience working in the deep sea, when she gets excited and we're onto something which we've seen around these seamounts that we've been working on. So to me, that means a lot. It means that we've really been in some very special places.
And now, because of the quality of the camera work and this connection, it looks like you could be in a high-tech office anywhere on land, but of course you're out on the high seas, you're researching the deep ocean. Alexis, can you give us an idea of some of the biggest challenges that you must face in the course of your work? Yeah,
so we're really fortunate to have a really fantastic vessel, and we have really good, internet connection now with kind of the development of better internet providers, Starlink and things like that. But over the years of doing this, there's always different challenges that come up with each mission. One of them that is always out of our control is weather and ocean currents. So, we have a capacity to operate up to a certain weather window, but sometimes Mother Nature has other ideas, and we just have to be okay with that. There's also always the complications. We're working with really high-tech equipment, so that requires having everybody on board that could handle any complication that comes up. And so what the ship does is it staffs in a way that we can repair most anything that were to have an issue while we're out here. But sometimes it's something that requires a new part, or we have to go back into port for. So there's things like that are out of our control. But we really do our best to come out with a team that can kind of handle any of the challenges that come our way. And normally we can make something work.
And now, this might be a silly question, but as someone who gets queasy on the Rotto ferry, is being a marine scientist, does it sort of automatically self-select? So if you get seasick, you're probably just not going to be in this field of research.
Or you learn which medication work for you. So there are folks that they've learned that they don't agree well with the movement of the ship, and so they figure out how do they combat that, or they decide that they're going to do the analysis on land, so they send somebody else to come do the work on the ship. But the other is that generally you give yourself 3 days or so, and you get your sea legs. So most people can acclimate after just a little bit of time on the ship.
Oh, that's good to know. And what's the biggest swell that you've encountered?
We have had maybe a couple meters on this expedition, so nothing too crazy, but 3 meters. You can feel it when you're on the ship. But there's other folks that have been sailing for a long time, and they could give you some serious stories about having to strap yourself into your bed and things like that.
Oh my goodness. Well, thank you both for this very insightful tour. Folks, can you put your hands together for Jen and Alexis? Okay, so now I believe you're going to find somewhere comfortable to sit in mission control because it's time for the audience to ask the questions. And so, folks, we're going to have a microphone that we'll bring around. So if you put your hand up, we will come to you. Wait till you've got the microphone so Jen and Alexis can hear you. And as a favour, could you please just avoid making any statements before the question? Just ask the question so we can get through as many questions as possible because we do have a limited time with the gang on the ship. So who wants to go first? Madam in the front.
I'm just wondering if it's possible to be a volunteer on such a sort of scientific exploration vessel. Volunteer.
So because of our types of operations, our ship is staffed really specifically to be able to cover all of the different things that we do. So we often don't have space for anybody that's not got a really specific job while we're out here. So while we love for people to get involved however they can, normally on the vessel it's trained professionals so that we can make sure we're utilizing our time well.
Can you take a moment to explain what's happening?
Okay, we've got somebody else.
Quickly, I'll say, Ben, behind us, you can see this screen. This is the ROV feed right now. So this is what the pilots and the scientists are seeing. So also if people have questions about what's going on, please feel free.
So if we see something that we think is new to science behind you, we'll just say, turn around.
Yes.
Okay. Okay, we've got another question.
What was your first discovery?
You want to go?
Oh, that's tricky. So my first discovery, well, I discovered a new species of fish in the Indian Ocean, the Northwest Indian Ocean. I haven't named it yet, but it's definitely a new species. So that's very exciting to be able to put a name to a species that's very new to science.
Oh, Jen, I've got an idea for a name. Why don't you just call it Ben? Could you call it Ben?
Ben I.
Oh, yeah, of course. Okay, now we've got somebody else. Yep.
How many species have you discovered?
That's a really good question. So a lot of the time we don't know for certain that something is new until a scientist like the curators at WAM can spend a good amount of time looking at it and comparing it to other animals. So we have discovered definitely, in the order and the magnitude of 100 new species aboard the OceanXplorer, but that number is always growing as we continue to do exploration like this.
Amazing. Oh, we've got another one.
How many seaweed have you found in your explore?
What is seaweed?
Yeah.
Yes, seaweed. We haven't seen a lot of seaweed. Seaweed, of course, requires light in order to live. And in these very, very deep environments, there is no light. It's completely dark. And so seaweed really can't grow at 2 or 3 or 4,000 metres where we're working on board the ship. So you'd have to go up into the sort of the shallow environments in order to find and study seaweed.
Okay, yeah, somebody else.
Hi, you said that you're taking samples from 3,000 metres below the sea surface. How does it affect the sample when you bring it up to the current air pressure that we have here on land?
Yeah, that's also a really great question. So like I said, there's immense pressure down there, but most of the sampling that we do is of either sediments, water, or invertebrate animals. And so they don't actually have much change. The pressure doesn't impact them because they have no air within their bodies. And so when you bring them up, they still look the same. They still have the same structure. But when we work with fish, that can be a different story. So the fish, we want to make sure we bring them up in a humane way and we work with them so that when we preserve them, they are going through a process that isn't harmful to the fish.
And also the other thing I'd like to add is the nature of this and the beauty about working with an ROV is it's highly selective. And it means that we take only a very few number of samples of the species that we're interested in. And that's really important to us. So we're not harming the environment in any way because we're taking, and you can see just how many animals, you know, we'll often just take a photograph and you can see just how abundant a lot of these animals are, and we've taken just very few samples on this particular dive.
Yeah, what's helpful, just for context with what Jen's saying, is that like the cameras, as Ben said earlier, are so high quality, they're so high resolution that if we get one representative of the physical sample, that means that we can then look at the video and compare it to the other ones that we see.
Yeah.
And it allows us to identify them just on the imagery.
I hope you guys are comfortable because there's a lot of kids here and I can see a lot of hands up in the audience, some in the front row as well. Alicia, you've got somebody else with a question?
Hi, I have two questions. The first one, have you found any DNA samples of species that you thought that we think had gone extinct? And the second question is, do you have an onboard medic?
Yeah, so I'll start with number 2. We do have an onboard medic, so we always sail with somebody who sails as a medical officer, so they're trained to handle anything that might happen. And then for discovering things that might be extinct, we have had some studies where we detect really interesting DNA that I can't quite speak about, but we definitely are often finding kind of the unexpected in the DNA samples that we sequence.
So the eDNA, the water samples, would certainly pick up DNA of things like whales, big marine mammals, dolphins. So that's the beauty about it. It can detect DNA without having to harm those animals in any way.
And so when you collect this DNA, you're comparing it to existing samples that are, say, in the WA Museum's collection. What happens if you come across something that isn't in a collection?
Yeah, that's a really good question. That doesn't happen very often because we have a pretty extensive collection to that end, and so what would happen in that particular instance is that the geneticist would then go and look at a global library of DNA sequences to try and track it down to see if they can actually, so there are these global databases that they can tap into and use and screen for the animals that they're detecting with DNA, if in fact, we're unable to help them.
Yeah, and one of the things that is interesting with eDNA, especially in the oceans, is that when you create the sequences and you're looking at and trying to match them back to those databases, so what are known sequences, and have a species identified with them, there's actually a high percentage of that total DNA that has no match because we haven't collected a sample of it somewhere in the world before. So that's where continuing to do the collections alongside the eDNA is really important, because every collection we make improves that detection ability. And with our folks from Oceanomics, they were talking about before that, they've done comparative studies to if they're just sequencing based on global data and comparing to global databases versus this type of pairing situation where we bring samples back from the area that they're collecting their water eDNA. They have a much higher rate of those detections matching something that they were collecting in that time.
Now we've got someone in the front row who's been waiting to ask a question. Take it away.
How much pollution and microplastics have you seen since you started your expedition?
That's a really good question. We actually haven't seen a ton of plastic or anything that's large enough for us to see on the seafloor, but there have been a number of studies that show that unfortunately there is a lot of microplastic kind of all over the ocean at this point. So we are always keeping an eye out, and we try and document that those types of observations when we see them, so we can have an understanding of how people are impacting these systems.
Okay, next.
Have you ever been in the submersible, and if so, how scary is it?
I have had the chance to go in our submersible and then in a couple others also, and for me, it's not scary. For me, it's probably the most exciting moments of my life. It's a really amazing experience to get to go down and observe the deep sea in real time. ROVs are really useful for their utility, but there's kind of nothing like the experience of being in the space yourself. Gives you a whole different perspective for what these habitats and ecosystems look like.
And there are 2 submarine technicians on board OceanX. They're incredibly well trained. The submersibles are maintained to a very high standard, and so they're very, very safe to that end. And they have a maximum depth range of down to about 1,000 metres, so no deeper than that.
And now I've got a question from a little girl who's had her arm up so high and so straight, I think she's going to need a physio after she asks this question. What's your question?
My question is, how many sea animals have you seen?
That's a really good question because we've seen a lot of sea animals.
Yeah.
So we are doing these ROV dives for about a whole day at a time. So we'll send the ROV down to the seafloor in the morning, and then it explores all day. So even today, we've probably seen thousands of sea animals that are on the seafloor, and then we also are looking at plankton, so really small sea animals that are in the water when we're looking at what's in the surface of the water too.
While we're just looking at the screen there and seeing the ROV, I've actually got a question that's come in from Christmas Island, from the audience dialing in from there. Their question is, do deep sea creatures ever show interest in the ROV? Do they swim up to it? Have they ever attacked it?
So they often are actually, they're normally not that interested in us. They don't, so one of the things that is on the ROV that we didn't talk about are a lot of lights. So as Jen said earlier, this is an area of the ocean that normally is in complete darkness. So things like fish that do have eyes, they don't love that we're shining bright lights on them, so they tend to kind of go the other way. But we sometimes see crabs and squat lobsters like this little guy right here, and they will definitely put their claws up and tell us to stay away if we get too close. Yeah. Oh, and then we have Ewan, our ROV pilot, is hearing the questions and chiming in that the ROV has been attacked or approached by a swordfish before. 3 different swordfish.
Oh, that's exciting, because I think the people in Christmas Island, maybe they've seen a Jason Statham movie, this giant, the Meg, if there's one of those down there, I don't know. And now we have a question here in the audience with us at the museum.
Have you ever seen a live oarfish before?
A live oarfish?
No, I have not.
I have not, and I would love to see one, but I have never seen one.
No.
Okay.
Ewan has. Ewan wants me to know that.
pilot.
He's seen a juvenile oarfish. When you think about who has the most experience looking at what's in the ocean, it's our ROV pilots, because they do this every mission.
Yeah.
Amazing. Okay, another question from the audience.
What is the weirdest looking species you've ever seen?
What do you think?
I think some of the fish that we're seeing on this expedition, because they're so unusual, they're often long-bodied. They look eel-like, the conger eels, and they're extraordinary-looking animals that live in very cold, very dark environments. So they're probably my favourite, I think. But I'm a bit biased because I'm a fish person. So
I think one of mine is, we saw one today earlier, which is, it's known as a sea spider, but it's called a pycnogonid. So it's a type of crustacean actually that looks like a spider with its long legs, and it creeps around. But they're quite strange.
Oh wow, there's something. What is that? Is that what's behind you right now?
That is a squat lobster. So it's related to a crab. And these ones we've been seeing them kind of in this region quite a bit, where they're white like that, and they have 2 claws, and then they have a tail, kind of like a shrimp, but it tucks it under. So when they swim, they actually swim backwards. You might see it if they end up spooking it.
That's a glass sponge.
Yeah.
That they're living on.
Yeah, wow. Okay, next.
We ever go to the Mariana Trench?
Oh, the Marianas Trench?
Yes.
No, oh no, has
No,
OceanX?
I don't think OceanX has. I personally have not, but there are other groups doing exploration in that area right now.
Yeah.
Okay, next.
And about the laser.
How long does it take to get to the bottom of the ocean?
Good question.
Yeah, that's a really good question. So the ROV descends at a certain speed, and so for us to get down to about 2,900 meters, hey Ewan.
So to get to our full operating depth of 6,000 meters takes about 2.5 to 2.75 hours.
So if we were going down to as deep as the ROV could go, which is 6,000 meters, so double where we're at today, it takes about 3 hours to get there. So for us, it took us about an hour and a half for the ROV to get to this depth this morning.
Yeah, wow. I've got another question from Christmas Island. They want to know more about seamounts in the ocean and why they have such biodiversity.
Yeah, so seamounts are essentially underwater mountains. And so if you think about the terrain of the seafloor, those mountains are made up of hard rock or a hard surface. And so the areas in between the mountains are what we call abyssal plain, and that's often soft sediment. So that's where all of that debris has fallen down. And what we found is that most of these, like what we call benthic communities, or animals that live kind of on the surface of rocks, they really like seamounts because they provide that habitat, which is a place that they settle and then they grow because they're not moving around. And so what the scientific community has kind of started to understand is that seamounts provide these kind of hot spots across the world's oceans for these communities to exist, even if there's not land nearby or other types of input.
I've got another question from someone here at the museum.
What is your favorite species of coral?
Oh, there we go.
That's my favorite question. I wish I could show you a picture, but my favorite species or group of coral are called bubblegum corals because they're bright pink and they're very beautiful.
They're really pretty.
But they can live really deep in the ocean as well as
and they're very old, right?
Yeah, they can grow. Most of the species that live in the deep ocean grow very slowly and they live to be very old. So the oldest coral ever age dated is over 4,000 years old. So these are quite ancient animals.
Well, this might be a question for you, Jen, that's come all the way from Christmas Island. How long does it take to train as a taxonomist to do the works that the staff at the museum and scientists are doing?
So most of our curators have PhDs, so they usually do an undergraduate degree in marine science, and then they'll go on and either do an honours or a master's. So that's sort of anywhere from 4 to 5 years. And then they'll go on and do a PhD, which usually takes anywhere from 3 to 4 years. And then they might do what we call a postdoctoral fellowship, which is another year or two after that. So yeah, a fair chunk of time, I would say, anywhere from sort of 7 to 9 years.
Yeah, wow. And we've got a question here from the kids at the front.
How long has OceanX been an exploring company?
Yeah, that's a good question. So the ship started exploring in 2021. So we have been kind of continuously exploring different parts of the world's oceans for the last 5 years or so.
Well, I think we have time for maybe one more question.
How many ammonite fossils have you found starting from today?
We haven't found any ammonite fossils, but on a previous expedition, we did see, when we were around the waters of Palau, which is in the Pacific, we saw live nautilus, which are essentially the descendants of ammonites.
Yeah.
Yeah, wow. Okay, folks, sadly, that's all we have time for today. Can you please put your hands together and thank our scientists, Dr. Alexis Wenig and Dr. Jen McIlwain.
Thanks, you guys.
Thanks.
Thanks, Jen and Alexis. It's been so great
Okay.
to hear from you and hear about your work. Really appreciate your time today. Thank you so much. And on behalf of all of us here at the WA Museum Bullabardip, I'd like to thank everybody who joined us for this special event today. From those who dialed in from Christmas Island and the audience here in Hackett Hall. Just a reminder that the OceanXperience exhibition is running through to October 11 this year, so make sure you check it out. And if you've already seen it, tell your friends. Make sure they come down and see it too, because we'd love to welcome them. Okay, folks, that's it. It's goodbye from us. Please make sure you get home safe.
Okay, bye-bye.
The questions are awesome.
See, now time won't take a hold on us. No devil below you, and no God above. See, 'cause heaven is right here, baby.